In this lesson, we're going to learn how to write isolated specs using test doubles. Sometimes testing an object requires too much setup, or the object can be heavily coupled to other objects. In this scenario, you end up writing an integration test that covers many elements of your system. These types of tests can be valuable, that's why we write request specs. Other times it can be valuable to isolate a unit under test. So instead of testing with all real objects, we focus on the object we're trying to test and use test doubles for other objects that we need. Let's assume we have the following service object, which invites users to an event or sends a failure notice to the host. This service is designed to receive complex active record user objects and event objects. It then talks to an email service that we do not want to actually trigger when running our specs. To test this in isolation, we only need to fake what is necessary to accomplish the test. For a recipient and host, we don't need full user objects. We just need something that responds to email and ID. For the event, we just need something that responds to approved. For the email service, we want to make sure the correct call is made to that service, but ideally we wouldn't cause the email service to actually run and send emails while we're testing. The problem with the ID field on a user is that it's generally set by saving to the database. Saving a user to the database requires it to be valid. We only care about the ID and the email, but we'd have to set up an entire user object with all of its data to make it valid, and then also all of the associated models it belongs to. It'd be a huge amount of setup and would cause the spec to run even longer just to get an ID and an email. There are other scenarios like this, where the setup pain is not worth it and actually detracts from the test itself. Let's use doubles instead. So first, let's set up our spec. We'll use doubles to replace the host, recipient, and event objects to avoid having to instantiate full objects. With the double, we pass a name and we can pass a hash of stub responses. In the hash, the keys are the methods the double will respond to, and the values are the responses the double will give. If we wanted to write a double for a duck that quacks when we call speak, we would write the following. And now when we call duck.speak, we would get quack. In this code, we have set up doubles for host and recipient that respond to ID and email with our stubbed values. We also made an event double for each of our contexts that responds appropriately to the approve method. The test will pass now, but we'll still be sending emails through the email service, which is something we'll solve in the next section using a mock. With mocking, we're able to not only stub a method out, but also make expectations that the method was called. This is perfect for our email service. We want to make sure that sendInvite gets called with the recipient's data when an event is approved. We also want to ensure that sendFailure is called with the host data when an event is not approved. In order to do this without actually making the calls, we can use mocks or spies. Generally in a mock, you set up the expectation during the arrange phase. This is counter to the typical flow of arrange, act, assert, because it places an assertion or expectation at the beginning, out of order. A spy in RSpec is a bit more verbose than a mock, but enables you to allow the call to happen in the arrange phase, but wait to expect that it happen until the assert phase. We'll add a mock to the approved event context and a spy to the unapproved event context. The difference using this RSpec syntax is around allow versus expect and receive versus have received. When we mock email service with this code, we are setting the expectation and intercepting calls to email service all in one line. We are expecting that at some point the sendInvite method will be called on email service with the arguments jane@example.com and 1. This prevents the real service from being called and provides us with guarantees that we are ensuring the call is actually being made when our spec runs. When we set the email service up as a spy with this code, we are intercepting the calls to email service and setting the rule that we are allowing our intercepted service to have the sendFailure method called on it, but not making any expectations that it will actually happen. It's not until the end that we make the expectation that email service had sendFailure with its arguments called. This allows us to maintain the flow of a range act assert, but at the cost of an additional line of code. Allow can also be used in scenarios where we don't care to make an expectation of a call and just want to allow it to happen without it in fact happening. Now, you need to use this code and test the invitation service. Follow the commented instructions in the code to complete the test spec.